Now, I should point out that there's quite a lot to learn here, but it's worth making the effort. It does come up in the exams, and you are meant to know the specific details. As we said in the last video, stars begin life as a cloud of dust and gas, and scientists call this a nebula. Gravity causes the cloud of dust and gas to collapse. As the particles move faster, the temperature rises to millions of degrees Celsius. This early stage is called a protostar. If the temperature gets high enough, then hydrogen nuclei join together to form helium nuclei. This process is called nuclear fusion, and we looked at nuclear fusion in an earlier video. At this point, we've got a main sequence star. Nuclear fusion releases a huge amount of energy, and stars can stay in the main sequence for a very long time. But what happens next depends on the size of the star, and you need to learn these stages. We're going to start by looking at what happens to stars that are about the same size as our Sun. So here's our main sequence star. As we said before, in a main sequence star, hydrogen nuclei fuse together to make larger nuclei such as helium. Now at some stage, the hydrogen in the star begins to run out. At this point, the outward force due to fusion energy is less than the inward force due to gravity. This causes the star to collapse inwards. The collapse of the star causes its temperature to increase. Now helium nuclei fuse together to create heavier elements, and the star expands to form a red giant. At some point, the red giant stops fusing helium. At this stage, the star shrinks and forms a white dwarf. Because the white dwarf's no longer carrying out fusion, it gradually cools down. Eventually, it stops releasing any energy and it forms a black dwarf. So that's what happens to stars that are about the same size as the Sun. Stars that are much bigger than the Sun follow a different pattern, and again you need to learn this. Once these stars run out of hydrogen, they leave the main sequence stage and they expand into red supergiants. Once again, helium nuclei fuse together to produce heavier elements. Now, there is one really important point here. In the stages we've seen so far, nuclear fusion cannot make any element heavier than iron. So the question is, where do elements heavier than iron come from? Well, at some point, the red supergiant stops carrying out nuclear fusion. At this stage, the star explodes, and scientists call this explosion a supernova. Now, the temperature of a supernova is high enough to produce elements heavier than iron. So remember that elements heavier than iron are only produced in a supernova, and you could be asked that in your exam. When the supernova explodes, these elements are distributed throughout the universe. After the supernova, the remains of the star can form one of two different objects. The first is called a neutron star. A neutron star consists of neutrons densely packed together. Instead of forming a neutron star, the remains can form a black hole. A black hole has such a large gravity that not even light can escape.